Alright, standard 8.5a is really just talking about perfect squares. Alright, it's identifying perfect squares, it's listing all of the perfect squares up to 400. Last year this was a problem because you'd actually have to do all the multiplication or the division depending on whether working forwards or backwards, but here we have calculators. We don't really need to go through the labor of doing that. We just need to understand the idea behind a perfect square, or a square root, or squaring something. We need to understand the vocabulary more than actually knowing how to do it, because we have the calculator that can do this stuff for us. Okay. One really practical application of a square root is the length of a side of a square. What is the length of the side of the square with an area of 81? This number, let's call that x, times that number, x. Those are the same number because it's a square. X times x would have to give us 81. Instead of trying to guess at this is why we would use a square root. We're going to take the square root of 81, and that tells us that each side has to be 9. Alright, we're going to list out 3 perfect squares here. I'm going to pick the easiest 3, although I'm going to skip over 9 since we just used that one. I'm going to do 1 squared, 2 squared, 3 squared would be the next one, but I know that's going to give me 9, so I'm going to do 4 squared. This is the easiest way to find perfect squares. 1 squared is 1, 2 squared is 4, 4 squared is 16. Those are 3 perfect squares. We can keep going up that list. 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, and we could find every single perfect square that we want. All right, now we're going to circle all the perfect squares. 7 does not have a number times itself to give us that number, so that doesn't work. This is 3 times 3. That one works. Negative 9 seems like it might work, but 3 times negative 3 is the only thing that would give us that, and those are not exactly the same number. They need to be exactly the same. That is not a perfect square. Same thing with 11. It's a prime number. There's no 2 numbers that are multiplied times each other to give us that. 25 is 5 times 5. That's a perfect square. So right now I'm just kind of saying these off the top of my head because I know these. 225 might be a little bit trickier, so I need to actually take the square root of that to figure out whether it is a perfect square or not. If I get a whole number here, which I do, I'm going to get the number 15. That's really just 15 times 15. If you get a whole number, if you don't get a decimal, that means that's a perfect square. Anytime you get a decimal, that's an irrational number. If you get a whole number, that means the original number that we had was a perfect square. That's a good one. Don't even need to figure out what that is. 8 squared. I know that's going to be a perfect square. I know already that that's 8 times 8. It's really 64, which I also know to be a perfect square. The square root of 400 would give us 20. So that's 20 times 20. That's a perfect square. Square root of 200 would give us 14 point something. Doesn't matter. It's not a whole number. I know that's not going to work. I'm going to simplify the parentheses part of this first and turn this into 8 times 8, which I just saw from that example. That is a perfect square. This is an example that I see a lot of people get messed up on because you just look at 64. And 64 is a perfect square, but this is really talking about the number 8. 8 is not a perfect square. So the square root of 64, which is just 8, is not a perfect square. The square root of 289 would give us 17. So that's 17 times 17. And the square root of 1 would give us 1 times 1. Alright, so we're just going to try to fill in the blank. 16 is a perfect square because, why is 16 a perfect square? There's a bunch of different ways we can describe that. The easiest way I have to describe it is because 4 times 4 equals 16, and 4 is a whole number. Alright, the reason I can't just write this first part is that 3.5 times 3.5 would give you 12.25. That's not a perfect square. Just because we have 2 numbers times themselves giving us this number doesn't mean this is a perfect square. It's not. It's important that 4 is a whole number. Okay. Blank is the square root of 9. Well, that's going to be 3. The square root of 9. Blank is 9 squared. That's squared. That's 81. The square root of a perfect square is always a whole number. That's exactly the point I was trying to make here. It's always a whole number. It's basically 0, 1, 2, 3, counting all the way up to as high as you can go. It's got to be a whole number, no decimals.